that introduction, Skylar. My name is Maxim, and my project is a robotic arm. I will be a junior at Pinnacle High School, and the reason why I chose this project is that it has servos, and I've never used servos before, and I wanted to learn more, and I had a few modifications in mind, which I'll explain later. And right now, I will demonstrate on how it works. I have my computer hooked up to a Bluetooth chip, and I can send commands to it, such as closing and opening the arm, and then controlling the yaw, moving the wrist, and then also moving the base of the arm. And also, I can control the motors, and they'll stop if there's an object in front of it and print the distance. And it has all 4 directions of motion. So originally, this project supported only HC05 Bluetooth modules, which is regular Bluetooth and works with Android devices. But I wanted to use it with my iPhone, and I didn't want to deal with coding my own app. I already had one in mind. So I asked for an HM-10 Bluetooth module, which uses low energy Bluetooth and is far superior than regular Bluetooth, as it can support power conversion, power conservation, and it can also send packets faster. What I mean by power conservation is after the module is done sending or reading data, it goes into a low power state, conserving battery. So that was my first modification that I added. And then the second biggest modification I added were the wheels, as originally this project was stationary and you would control it via joysticks or an Android. That was the biggest modification. And then I added LED lights so it could work in the dark. And also I did terrain testing, it can work on gravel and grass. And additionally, this Bluetooth chip has up to 50 feet of range with no obstructions. And after further testing, the robotic arm can lift up to 50 grams on a full charge. And the way I was able to get to the 50 grams, it was with the electrical tape and the rubber bands. Another modification that I added was ultrasonic sensors, so it would stop the motors if it was driving in any direction, but then I later changed that. That was another modification I added. I later changed it so it would print to the Bluetooth serial monitor wirelessly, and it would also print the distance if there was an object detected in front of it, which is within 25 centimeters, it will stop the motors. And then the biggest challenges I had with this robotic arm car was power. These servos would start twitching originally out of control, and if I would have put in an input via Bluetooth or joystick, it would just fling around and it would result in breaking the servos. And I later down the line learned it was to deal with voltage, and they need 5 regulated volts to work properly, and I fixed that by using a voltage regulator, but while implementing an ultrasonic sensor, I fried that. So I opted to using a motor driver that outputs regulated 5 volts, and it's a lot more difficult to fry. Also, on motor drivers, I'm using one down here to control the motors, and motor drivers, specifically my L298N motor driver, uses H bridges to reverse the polarity of electricity so the wheels can spin either clockwise or counterclockwise to give it the ability to either move forward, left, right, and backwards. And then for future modifications that I would work on this project is making the robotic arm bigger, as these are 9 to 12 gram servos and have only up to 2.5 kilograms for 1 centimeter of torque, which is pretty bad because most of that goes to the robotic arm itself and doesn't leave a lot of room to lift stuff up, as it can only lift up to one 9-volt battery, which isn't a lot. So that would be a modification I would work on. And also the reliability of this, because there's some parts that are really janky. For example, if I were to unplug the ultrasonic sensor, the driving capability just completely goes down the line, because the ultrasonic sensor will send noise to the Arduino Nano, and the Arduino Nano will think there's something in front of it and causing the motors to stop. My time at Blue Stamp Engineering was highly enjoyable, as the instructors, especially Skylar, would help me out on the power issues and help me reach this final product. Does anyone have any questions?